All right, people. I believe everybody is doing great, nice, and absolutely fine. So, welcome to Unacademy NEET English. Please let me know in the chats if I'm perfectly audible, visible to each and every single student. So, today we have an important session, okay? All right, people. Okay. So, guys, we are almost done with the vectors. This is the third part of the vectors, and here we are going to basically get done with we say the dot product, the cross product, extremely important, and we say parallelogram law, and apart from that we say polygon law. So these are the things we are going to discuss in this particular we say session, and we are done. We are done. We are done with this. Okay. Okay. So my dear friends, please let me know in the chats if everything is crystalline clear. Let me know in the chats if everything is crystal and clear. Okay. Am I perfectly audible, visible to each and every single student? Am I perfectly audible and visible to each and every single student? Great, 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 great. Sir, Wasim sir roasted you in 6 p.m. class today, Phoenix batch. Okay, Wasim sir roasted me in the Phoenix batch today. Yes, yes, I heard that. I heard that. Okay. Now, guys, sir, why did you delete your recent video today? Because we got the another tweet from the ANI News that they have basically taken that they'll be basically filing the another affidavit in the Supreme Court. That's the reason we had to take that down. Okay. Now, my dear friends, in this particular case, we are going to discuss that is we say cross product and dot product of the vectors. And before that, let's basically start with the parallelogram law of vector addition. Parallelogram law of vector addition. My dear friends, you can clearly see that. See. Let me recall when I told you about the triangle law of vectors. I hope you remember each and every single thing when it comes to the triangle law of vectors. What did I tell you in case of the triangle law of vectors? Sir, triangle law is basically that law. Guys, let me switch off these lights because there is an electricity will come at 7 p.m. Okay, so till then I'll have to switch these off. So we say triangle law of vectors basically say if we have got a vector over here, let's suppose that is A. If we have got a vector, let's suppose A. And if we have got vector, let's suppose we have got vector B. And if we have to find the resultant of these two vectors, if we have to add these two vectors, the law says that you represent these two sides, you make the two sides of the triangle with the help of these two vectors. And then third side will be given by the third side. So resultant will be given by the third side. Okay. So triangle law simply helps you to find the resultant of the two vectors. So we say this resultant is simply that is under root of that is a square, this vector square, plus we say b square, this vector square, then we say plus 2ab, and then we say cos of theta, where theta is the angle between a and b. So this we have already studied. So triangle law helps us to find the resultant of the two vectors, and that's we already studied. Now when it comes to the parallelogram law, my dear friends, you take a look over here. We say parallelogram law of vector addition. It states that if two vectors acting on a particle at the same time can be represented with magnitude and direction by the two adjacent sides of the parallelogram drawn from a point, then their resultant vector is represented in magnitude and direction by the diagonal. As when it comes to the triangle law, you say, sir, with the help of one vector we make one side, with the help of another vector we make another side, and with the help of the third side we get the resultant. But when it comes to the parallelogram law, okay, when it comes to the parallelogram law, my dear friends, listen to me very, very, very carefully. Let's suppose we have got a vector over here, okay, and let's call this vector as A. And we have got, let's suppose, another vector over here, that is, I'll make it over here, that is vector B, okay. And I have to add these two vectors. The first method that I have in front of me is triangle law. Sir, what do we do in triangle law? We take these two vectors, make two sides, and third side will give the resultant. But I say use parallelogram law. What does that say? See, that says, we say do the parallel shifting of the vectors. Guys, see. I'll show you over here. I'll take this vector A and I'll make it over here. This is vector A. And I'll take this vector B, I'll make it exactly over here. I'll make this vector B exactly over here. Okay. Now, my dear friends, see. We can parallel shift the vectors only and only if the direction and magnitude is same. See, here direction of A, here direction of A, here direction of A, here direction of B. Can I not show, guys, listen to me very carefully. If this is vector A, this is vector B, I can say, sir, I can make one more vector. This is also called the parallel shifting. I can make one more vector which is exactly like this vector, which is A. Means I have parallel shifted this vector over here. See, direction of this vector, exactly same. And I can parallel shift this vector over here, that is vector B over here. Now, guys, don't you think this looks like a parallelogram? Yes. See, what is the method? Take this vector, place it over here. Take this vector, place it over here. Now, do the parallel shifting once again. Another vector, we say we can make it over here. Exactly similar. Parallel shifting of this vector. Now, guys, in this particular case, we say the resultant will be given by this diagonal. If the angle between A and B is, we say, sir, theta. In this case, a resultant is given by the diagonal. So that is what is mentioned in the law itself. In case of parallelogram law, if you have to add the two vectors, we say in that case, a resultant will be also given by the resultant is represented in magnitude and direction by the diagonal of the parallelogram. Guys, please, and when it comes to the triangle law, we say resultant is represented by the third side. Please tell me in the chats, is this clear? I would want everybody of you to tell me in the chats if it is clear, crystal, to each and every single student. I am looking at the comments. Guys, tell me in the chats. Everyone means everyone. Tell me in the chats. Now see guys. Yes, great. Now see guys. Sir, this resultant will give us this R will give us the basically resultant of A vector and B vector. And here also we say value of this resultant will be simply that is A square plus this vector B square plus 2AB, and then we say cos of theta, where theta is the angle between A and B. Okay, yes sir. So we say this is A vector, B vector. Their resultant is, we say, sir, R. R is equal to under root of A square plus B square plus 2AB. Now guys, in this particular case, I would want you guys to understand one thing. Sir, what about the proof of this one? I have already shown you the proof of this one. Okay. Now, if I talk about, sir, this angle, this is, let's suppose, angle alpha. This is the angle between resultant and A vector. I'll say over here angle between resultant and we say A vector. Angle between resultant and A vector, I can say that is alpha. Angle between resultant and A vector is alpha. And if you remember, in case of the triangle law, what was this angle? So we say over there, sir, this angle was tan of alpha was, sir, component of this one, that is B sine of theta upon, then we say A plus B cos of theta. Same value will be exactly over here also. Same value will be exactly over here also. So I would want you guys to keep this in your mind. I would want you guys to keep this in your mind. So guys, when it comes to the parallelogram law, so we say in case of the parallelogram law, resultant is represented by the diagonal, and the value of resultant is exactly same as the triangle law. And when it comes to triangle law, resultant is represented by the third side of the triangle. That's it. This will be the resultant over there, and this is the tan of alpha over here. This is the tan of alpha over here. I hope this is crystalline clear. I hope this is crystalline clear. I hope this is crystalline clear. Now, let's move on to the next law, and that is what we call the polygon law of vector addition for more than two vectors. If you have to add two vectors, you use either triangle law or parallelogram law. But when it comes to the polygon law, this is the law which is used to add, we say, more than two vectors. Like we say, it states that if n number of vectors acting on a particle at the same time are represented in magnitude and direction, means all of those vectors, n vectors, have got the magnitude and direction by various sides of an open polygon taken in the same order, then their resultant is represented in magnitude and direction by closing side of the polygon taken in opposite order. See guys, I'll make you understand. Let's suppose we have got many vectors over here, 1, 2, 3, 4, and you have to add all of these vectors. Sir, can we use triangle law? No, that's used only for adding two vectors. Sir, can we use parallelogram law? No, we can use that only for adding two vectors. So we have got many vectors over here. First, let's do the parallel shifting. I'll take this vector A and I'll place it over here. This is the vector A. This is the vector A. Sir, I'll take this vector B, I'll place it exactly over here. Here, direction of vector B is something like this. Here also it will be something like this. I'll take this vector C, which is in the backward direction, and I'll place it something like this. And I'll take this vector D, I'll place it something like this. Its magnitude and direction same. Now, when it comes to the resultant, guys, you close this polygon over here with this side. This is what we call the closing side. So we say this is the closing side of the polygon. So closing side will give us the resultant in this particular case. Closing side will give us the resultant in this particular case. And we say this resultant will be A vector plus B vector plus C vector plus D vector and so on. And that's it. We don't have to go in much detail in this particular case. This is more than sufficient. That's it. Guys, tell me in the chats, is this clear, crystal and clear to each and every single student? Tell me, guys. Is this crystal and clear to each and every single student? I would want you guys to tell me in the chats. Everyone means everyone. Great. And one more thing, guys, most importantly, I would want you guys to like this particular session as soon as possible, because liking the session is extremely mandatory. Okay. Now, let's move on to the important concept of the today. That is what we call the dot product of two vectors. That's what we call dot product of two vectors. Guys. Previously, I told you the addition of two vectors. Okay. Like in case of addition, I told you, if we have a vector, let's suppose A is equal to 4i plus 3j. Okay. And if we have a vector over here, we have got that is 3i plus 6j. Okay. I told you how to add these vectors previously. Cool? Yes. Now, the point exactly is we have to do the dot product, like we have to do the multiplication of the two vectors. Okay. We have to do the multiplication of the two vectors. In multiplication, we have got two products. The first one is dot product and the second one is cross product. What does dot and cross product mean? Guys, listen to me very carefully. Like if we talk about the addition, like you have vector A, you have vector B. You say, sir, addition will be simply that is R vector is equal to A vector plus B vector. This is what we call the addition of two vectors. Simply. Okay. And if you find the magnitude under root of A square plus B square plus 2AB cos theta. Okay. But when it comes to the dot product, see, in multiplication, you have two product, dot and cross. Like guys, let's suppose we say, when it comes to the dot product, we say, I'll write something like this. If we have got two products, if we have got two vectors, if we have two vectors, and we have to do the dot product. If we have two vectors and we have to do the dot product, what we are supposed to do in that particular case, I would want you guys to understand very carefully. Guys, see. Let's suppose we have got a vector over here that is A. Okay. And if we do its dot product with the vector B, something like this. This is A vector dot B vector. And then we can say its dot product will be simply magnitude of A, and we say magnitude of B, and then we say cos of theta. Okay. Sir, you are not taking classes in 1 week. Nimbus, you are not. Guys, I'll be scheduling the classes from tomorrow onwards in the Nimbus. Okay, there will be regular classes. Chill. No issues. Okay. So we say dot product simply means if you have a vector A, if you have a vector B, if you do the dot product, you simply say magnitude of A, magnitude of B, and then we say cos of theta. This is what we call the dot product of two vectors. This is the dot product of the two vectors. Okay. Just put up this in the box. Cool? Yes. Now, my dear friends, I would want you guys to understand one thing. From here, if somebody asks you to find the value of cos theta, you can say, sir, value of cos theta will be simply, that will be this vector A vector, we say B vector divided by, we say mod of A vector, mod of B vector, mod of A vector, this mod of A, mod of B. This is the value of cos of theta. This is the value of cos of theta in this particular case, Okay. And when it comes to the dot product, I say it is scalar product. Sir, what is that? That is the dot product of two vectors will always give you the scalar quantity. It will always give you the scalar. Okay. So like if we do A dot B, it will give you the scalar. Now, my dear friends, let's suppose I say, if we have over here, sir, I, and we say, sir, I dot I, like we have I is a unit vector and I is a unit vector. We know that I is that unit vector which is along x-axis. And my dear friends, magnitude of unit vector is always 1. We say I dot I. Can you please tell me what is the value of I dot I? You say, sir, it will be, if we do the dot product of two vectors, it is magnitude of A, magnitude of B. Here, magnitude of I is 1, magnitude of I is 1. And then we say cos of theta. I is that unit vector which is along x-axis. I is that unit vector which is along x-axis. So both these vectors are along x-axis. So how much is the angle between the two? We say, sir, 0. So we say cos of 0. And cos 0 is 1. 1 into 1 into 1. So it will come out to be 1. So I dot I is 1. And if I ask you one more question over here, if I say what is the value of j dot j, sir, when it comes to the j dot j, you simply say, sir, magnitude of j, that is 1, magnitude of j, that is 1, because j is the unit vector which is along y-axis. And then we say, sir, cos of 0 degrees over here also. Why? Because both of these two vectors are along y-axis, so it will be cos of 0. Now here it will be also 1. Similarly, if we say when it comes to k vector dot k vector, this will also come out to be 1. K dot k is 1, I dot I is 1, j dot j is 1. So this is, you guys need to keep this thing in your mind. One more thing I would want you guys to understand over here. Let's suppose, my dear friends, if somebody asks you, what is the value of I vector dot j unit vector, I dot j. I is the unit vector along x-axis. We say j is the unit vector along y-axis. So I can say in this particular case, sir, mod of I is 1, mod of j is 1, and then cos of theta, angle between I and j is 90 degrees. So cos of, we say, 90 degrees over here. And cos 90 is how much? 0. So this will come out to be 0. I dot I is 0. Even if I say I dot j is 0, and if I say j dot, we say, sir, k, that will come out to be 0 also. J dot k is also 0. And if I say, sir, k unit vector dot I, that is also, we say, sir, 0. Because angle between k is the unit vector along z axis. And we say I is the unit vector along x-axis. So angle between these two is also 90. So this will also be 0. So remember, my dear friends, I dot I is equal to j dot j is equal to k dot k. And that is equal to 1. I dot j is equal to j dot k is equal to k dot I is equal to 0. Is this clear? Is this clear? Okay. Cool. So from now onwards, you will remember that if the angle between the two vectors is 90 degree, we say their dot product will be 0. Okay. So I'll mention over here. If A vector is perpendicular to B vector, then I can say A dot B. Then I can say A dot B is equal to 0. Why? Because the angle between these two is 0. That's why A dot B is 0. Okay. Okay. Thank you, Mehran sir. Good to see you. Cool, guys. Cool. Now, my dear friends, let's talk about a small topic over here. That is projection of a. Okay, one more thing I forgot to tell you. And what is that? See, guys. Let's suppose if I say, if A vector is given as, we say, AX I cap, then we say plus AY J cap, then we say plus AZ, we say, sir, K cap. Means I have got a vector A over here, which is in x direction also, y direction also, and z direction also, means it's in 3D. It's in 3D. Okay, like it is something like this: 2i cap plus 4j cap plus 3k cap, something like this. So we have got a vector which is in I cap, we say, which is in x direction, y direction, and z direction. Now guys, see. And if we have got another vector over here, let's suppose that is b. This vector b, it is also in x, so bx into I cap. We say plus, we say by into j cap. Then we say plus, we say bz into, we say, sir, k cap. Okay. Now, my dear friends, if somebody asks you to find the value of their dot, find, I say, find, we say a dot b, find a dot b. Guys, when it comes to the a dot b, if you have got these two vectors, always remember, this is in terms of components. These two vectors are given in terms of components. Okay. If these two works are given in terms of the components, how can we find their dot product? Remember, guys, if this is the x, this is the vector which is along x-axis, means here it is I cap, here it is I cap. So you simply multiply this with this. Now guys, I can say in this particular case, a dot b will be, see, ax into bx, I with I, j with j, and k with k. So I can say over here, this will be ax into, we say, sir, bx. Now, this I dot I, recently I told you, when it comes to the I dot I, that is, we say, sir, 1. So I dot I is 1, I don't have to write that. Okay. Then we say plus. I say ay into by, I can write this as it is over here. That is ay into, we say, sir, by. Ay into by. J dot j is 1. Then we say plus. I say az into, we say, sir, bz. Az into bz. K dot k is again 1. So this is the dot product of two vectors in terms of the components. Okay. Like we have got a question over here. This is the question. The question we have, find a dot b. If a vector is given as this is the a vector over here, and b vector is given as this, and we are supposed to find a dot b. Guys, see, when it comes to a dot b in this particular case, I would want you guys to understand. Here I cap with I cap, multiply I with I, j with j, k with k. Now see, 3 into 2 is how much? We say, sir, 6. I into I is how much? We say, sir, 1. So this will be 6. Plus 4 into 3 is how much? That is 12. So I can say 12. 4 into 3 is, we say, sir, 12. So we say, sir, 12. And j into j is 1. 2 into minus 1 is minus 2. So I can write minus 2 over here. So k into k is, we say, sir, 1. Now I can say over here in this particular case, so 12 plus 6 is, we say, 18. Minus 2 is, so it is 16. Now what is 16? Is it scalar? Yes, it is scalar. It is not, nothing is mentioned over here, I cap, j cap, or k cap. It is scalar. That's why I told you dot product of two vectors is a scalar quantity. Okay. Now, one more thing over here, that is what we call the projection of two vectors. See. I'll make you understand this particular concept. Guys, see, let's suppose we have got a vector over here, and this is the vector A. Okay. And I have got vector over here. This is the vector B. And this is the angle theta over here. This is the angle theta over here. Okay. This is the angle theta over here. Okay. Now guys, see, I have a vector A over here. I have a vector B over here. Now, my dear friends, can I say that component of this A vector on B vector, guys, if I make the component of A vector on B vector, can I say this component will be A cos of theta? Yes. And this will be A sine of theta. We know, sir, if angle is from this side, so this will be cos component. Either you say this is the component of A vector on B vector, or you say this is the projection. This is the projection of A vector on B vector. So we say, I'll write over here projection of A vector on, we say, B vector is we say, sir, that is A cos of theta. Projection of A vector on B vector is what? We say A cos of theta. Now, guys, tell me one thing. We recently studied as we say cos of theta. What is the value of cos of theta? Come over here. Cos theta is A dot B upon, we say, A mod of A mod of B. So I can write over here, it is simply A vector B vector upon, I say, A into, we say, sir, B. Either you say mod of A into mod of B, or you say simply A into B. It's one and the same thing. It is one and the same thing. Now guys see, I can say, we can put up this over here, so I can write over here. So we say this is A, and when it comes to the value of cos theta, that will be simply over here, that is A vector into B vector, A vector B vector upon A vector, we say, sir, B vector. Don't you think that we can cancel and this? Yes. So here it remains, we say it will be simply A vector, it will be B vector divided by, we say, sir, B. Now, I have told you before also, if you have to write the unit vector of any vector, if I say, let's suppose I say over here, I have A unit vector. How do we write this A unit vector? We say, sir, it is vector A divided by magnitude of A. If you have, let's suppose, B unit vector, you can write it something like this, that is B vector divided by magnitude of B vector. Same I can do over here. So I can write over here, that is A vector B vector upon magnitude of B. B vector upon magnitude of B will be the unit vector of B. So my dear friends, from now onwards, you can say simply projection of A vector on B vector, projection of A vector on B vector, or component of A vector on B vector is simply A vector into unit vector of B. A vector into unit vector of B. Guys, is this clear? Please tell me in the chats. Is this clear? Is this clear? Please tell me in the chats. And if you have not liked this session, and I would want you guys to like this session as soon as possible. Liking the session is extremely mandatory, guys. Okay. Okay. Guys, give me the signal in the chats if everything is crystal and clear. If everything is crystal and clear. Okay. So we say projection of A vector on B vector is A vector into B vector. A vector into B unit vector. Similarly, we can use the same logic. Guys, see, I can say projection of B vector on we say A vector is we say that will be B vector into unit vector of A. Using the same logic, you can exactly prove it. Okay. Okay. Like my dear friends, let me show you over here. Let's suppose I told you this is B vector. and I told you this is a vector. I told you this is a vector. Okay, this is a vector, and this is, we say, sir, theta. Now, can you tell me which component of B is along A? You can say, sir, this component will be simply, that is B cos of theta. B cos of theta. And from this side, it will be B sine of theta. Now, can I say over here, projection of B vector on A vector, or projection of B vector on A vector is what we can simply say, that is B cos of theta. And when it comes to the cos theta, I can write it something like this. Cos theta, I recently told you, that is A vector into B vector divided by mod of A mod of B. Now this and this will cancel over here. So what remains? A vector divided by mod of A into, we say, sir, over here B vector. Now guys, in this particular case, could you please tell me what is A vector divided by A? Sir, A vector divided by A is unit vector of A. So I can write this will be unit vector of A into, we say, sir, vector of B. Unit vector of A into vector of B. So this is, we say, projection of B on A vector, I hope both of these concepts are clear. Now, one more thing. If let's suppose you are given over here vector A, if let's suppose you are given over here vector B, and they ask you to find the value of angle between the two vectors. Guys, as we say, when it comes to the A dot B, dot product of two vectors, we say simply it is A, B, we say, sir, cos of theta. Mod of A, mod of B into cos of theta. Here, if we find the value of cos of theta, can I say this will be simply, that is A vector, B vector. This A vector, B vector divided by, we say, A into B, mod of A into mod of B, mod of A into mod of B. Okay. Now guys, tell me, in this particular case, we have to find the angle between the two vectors. So I can write over here, this is cos of theta is equal. Now A vector, B vector. What is the value of A vector over here? We know, sir, it is given as this much. We know, sir, B vector is given as this much. So instead of A, I can write over here, this is 3i cap, and then we say plus 4j cap. Okay. And when it comes to the B vector, so B vector over here is, we say, sir, 12i cap. Okay. Then we say plus 5j cap. 12i cap plus 5j cap. This is actually A dot B. So this will be dot. Okay. And then whole divided by magnitude of A. How do we find the magnitude of A? I can say that is under root of, we say, sir, 3 square. This square plus this square plus, we say, sir, 4 square. Okay. And then magnitude of B. How can we find the magnitude of B? You can simply say that is 12 square plus, we say, sir, 5 square. 12 square plus, we say, sir, 5 square. 12 square plus, we say, sir, 5 square. Okay. Now, my dear friends, in this particular case, what is the value over here? See. In this particular case, you will have to multiply this with this, because this is a dot product. In case of the dot product, I have told you over here itself. See, if you have got two vectors and you have to find their dot products, we have I multiply I with I, j with j, k with k. Same is the case you guys are supposed to do over here. And then root of this plus under root this plus under root this. Guys, is this clear? Please tell me in the chats. Everyone means everyone. Okay. Okay. See, now 3 into 12 and 4 into, we say, sir, 12. Now this will be 3 into 12 is, we say, sir, 36. And I cap into I cap. I cap into I cap will be how much? That is 1. Then we say plus. Sir, 4 into 5, that is 20. J cap into J cap is 1. Then we say upon. Now, under root of 3 square plus 4 square. 3 square is 9, 4 square is 16. 16 plus 9 is 25. Root 25 is, we say, sir, 5 plus. And 12 square, 144. And 5 square is 25. So then it will come out to be, we say, sir, 13. So this will be 69, 169, and that will come out to be 13. Okay. Okay. This is basically the final answer in this particular case. Guys, is this crystalline clear? Is this crystalline? Okay, this is not plus over here. This is not plus over here. This is multiplied by 13. This is 5 into, we say, sir, 13, because they are in multiplication. Okay, this is the answer in this particular case. This is the answer in this. Yes, 56 divided by 65. 56 divided by 65. Yes, yes, great, great, great. I hope this is crystalline clear. Okay, 50, what is this? 56 divided by, we say, sir, 65. Okay, 56 divided by 65. Okay, great, great. Now, I have told you everything about the dot product. Okay, now we have to talk about the cross product. Okay, either you call it the cross product or you also call it the vector product. Vector product. Either you call it the dot product, cross product, or you call it the vector product. Because when it comes to the dot product, we say resultant, final value of the dot product is a scalar. But when it comes to the cross product, it will give us the vector quantity itself. Now see guys. Let's suppose we have got a vector A. Let's suppose if we have two vectors. If we have two vectors, we say A and we say B. If we have two vectors, we say A and we say, sir, B. A and B. And we have to find its cross product. Or we can say we have to multiply these two, A and B, using cross product. You can also say it something like that. Okay, so we say if we have two vectors A and B, we have to find their cross product, or we have to multiply them using cross product. See, I'll write it something like this: A vector, then I say over here cross B vector. In case of dot, I used to write A vector dot B vector. Here I'll write A vector cross B vector. And this will be simply I say A mod of A, we say, sir, mod of B, and then we say sine of theta into, we say, sir, n cap. Sir, this n cap gives us the direction of A cross B, because A cross B is the vector itself. A cross B is the vector itself. So I can put up this in the box over here. I can put up this in the box over here. Okay. Okay. So I'll write where n cap is a unit vector. Where n cap is a unit vector, which gives the direction of A cross B. Sir, in the previous case, you didn't mention about the direction of A dot B, because A dot B is a scalar product. A dot B gives you the scalar quantity. A cross B gives you the vector quantity. Now, let me exactly show you over here. That will give you the crystal clear feel. See guys. Let's suppose we have got a vector over here, that is vector A. Okay. And let's suppose we have got vector over here, that is vector B. And if I ask you to basically add these two vectors, you say, sir, I can find the resultant of these two vectors, that is R, that is this R. And the value of R is simply A plus B, A vector plus B vector. Okay. And this is under root of A square plus B square plus 2AB cos of theta. But, if I say you have got A vector, you have got B vector, and you have to find their cross product, value of cross product, you have to do the cross product. You say, sir, this will be the A cross B, A cross B. We say, sir, this is vector C. So cross product of two vectors is a vector quantity itself. So means this is the resultant of these two vectors, and this is the cross product of these two vectors, that is C. And why did I make the direction over here? Because we say cross product of the two vectors is a scalar. Sorry, is a vector. So we say where C vector is A cross B. C vector is A cross B. And gives and is perpendicular to the vector A and vector B, and is perpendicular to the vector A and vector B. Guys, see clearly, if I say this is a plane over here, in this plane you have got vector A, in this plane you have got vector B. Now you have to do the cross product. So cross product, the direction of that vector, which will give you the, which is given by cross, will be perpendicular to A vector and B vector, will be perpendicular to A vector and B vector. Guys, please tell me in the chats, everything is crystalline clear till over here. Let me know in the chats if everything is crystalline clear till over here. Everyone means everyone. And hit the like button if you have not liked the session yet. I would want you guys to like this session as soon as possible. Okay. Yes. Now guys, this is basically, this was all about the cross product. One more thing I just want to tell you over here. What is that? Just a second. I say, if somebody says, what is the value of I unit vector cross I unit vector? What is the value of I cross I? So value of I cross I means A cross B. A cross B is simply mod of A, mod of B, sine of theta. So don't you think I can write over here, this will be mod of A. Mod of A is 1 because this is 1. Then mod of B is also 1 because I is also unit factor. Then we say sine of, guys, what is the angle between I and I? Both are along the x-axis, so that is 0. So I can say sine of 0. Sine 0 is 0, so this will be 0. Similarly, if I say J cross J will also come out to be 0 using the same formula. Similarly, if I say K cross K will also come out to be 0 using the same formula. But my dear friends, remember one thing. If I say you have to find the value of I cross J, I is the unit vector along x-axis, J is the unit vector along y-axis. So I can say in this particular case, this is what, guys, I'll be sending you the PDF in the Telegram group. Please. Okay. Now see, I cross J. So we say that is mod of I, mod of J. Okay, mod of J is, we say, sir, 1 itself. Okay. Then angle between these two, we say, sir, sine of 90. So sine 90 is 1. So this is 1 into 1 into 1 is 1. So I cross j is 1. And similarly, we say, sir, j cross k. J cross k is also 1. And similarly, we say k cross I. K cross I is also 1. So remember this, my dear friends, when it comes to I cross I, that is 0. J cross j is 0. K cross k is 0. Okay. Okay. And when it comes to I cross j, that is 1. J cross k is 1. K cross I is 1. And if you remember in the dot product, it was just the opposite. In case of dot product, it was just the opposite. Okay. Now, one more thing I just want to tell you over here. I'll write over here, finding the cross product in terms of components. Like. See guys, I'll make you understand. Let's suppose if I say A vector is given as, I say it is AX into I cap. We say plus AY into J cap plus we say AZ into K cap. Similarly, if I say B vector is equal to, we say Bx into I cap plus we say By into J cap plus we say Bz into K cap. If we have got these two vectors over here in terms of components, like this vector is in the x direction, y direction and z direction. This vector is also in the x direction, y direction and z direction. In this particular case, if I say what is the value of A cross B? What is the value of A cross B? Guys, if I would have asked you what is the value of A dot B, you would have simply said, sir, A dot B is AX into BX plus AY into BY plus AZ into BZ. But when it comes to A cross B, there is something very important you guys need to know. See, how do we find the A cross B? I'll write over here A and I say over here A cross B, okay, is equal to. Now, I'll make that determinant, okay, I'll take one line over here, I'll take another line over here. Guys, you have to do exactly the same. You are supposed to do exactly in a similar way. I'll take one line over here and I'll take one line over here. And then I'll write over here, this is I cap. I'll write over here, this is J cap. And I'll write over here, this is K cap. This is I, J and K. Okay, yes. Now guys, this is what we call the determinant. This we study in the 12th class mathematics. Since you guys are the medical students, you don't have to, you will be studying over here. If you have to find A cross B, what you are supposed to take two lines, then write I, J, K. Now, we write the component, what is with I? We say that is X, AX. What is with I over here? That is BX. So you write over here AX and you write over here BX. Okay. So you have to write, we say coefficient of I over here from vector 1, from vector 2, AX, BX. And over here AY and we write over here BY. Over here AZ and over here we say, sir, BZ. This is what we call the determinant. Now, once we are done with this determinant, now solve the determinant. Now we are supposed to solve this determinant over here. Okay. Now see, how do we exactly solve this determinant? My dear friends, listen to me very carefully. I'll write over here A cross B. Is equal to. Guys, see, very carefully. The first thing is, you have to basically solve this. What you are supposed to do, let's solve it for I. So I'll write over here, this is I cap. We'll solve it for I. Guys, see, I say this I This I is present in which column? First column, second column, or third column? Sir, it is present in the first column. So hide this column. So hide this column. And this I is present in which row? First, second, or third? Sir, first row. So hide first row and first column. Hide first row and first column. First row and first column. What remains over here? AY, AX, BY, BZ. Now do their cross multiplication. So I can say that will be AY into, we say, sir, BZ. Then minus BY into, we say, sir, AZ. BY into AZ. Then we say, now solve it for J. Then we say minus, put the negative sign over here. Then we say solve it for J. Okay, solve it for J. Now, we say J is present in the second column, so hide it. J is present in the first row, so hide it. Now, if you hide these two, what will remain over here? We say, sir, AX, BX, AZ, BZ. Do the cross multiply. So that is AX into, we say, sir, BZ minus BX into AZ, BX into AZ. Then we say plus, solve it for K. First, here you write minus, here you write plus. Now solve it for, we say, sir, K. Solve it for, we say, sir, K. I hope this is visible. I hope this is visible. Then solve it for K. Now, K is present in the third column. K is present in the first row. So hide this and this. What remains over there? These four. So AX into BY, BX into AY. So I'll write that is AX into BY minus, we say, BX into AY. BX into, we say, sir, AY. So this is the value of A cross B. This is the value of A cross B. That is AY BZ minus BY AZ, then minus this, something like this. Let me basically solve a question on this, which will give you the more feel, which will make you more clear over here. Now guys, see. Here, in this particular case, this is the A vector and this is the B vector. You guys are supposed to find A cross B. What is the first thing we guys are supposed to do? We say, sir, A cross B. So we make the determinant over here. So I write I cap, I write J cap, and I write over here K cap. Now, here I have to mention what is with I cap. What is the coefficient of I in the first vector? That is 1. So I write over here 1. Previously it was AX, right now it is 1. What is the coefficient of I in the second vector? That is 3. So I write 3 over here. Now what is the coefficient of J in the first vector? That is minus 2. I write minus 2. What is the coefficient of J in the second vector? That is minus 1. So I write minus 1. What is the coefficient of K in the first vector? That is 4. What is the coefficient of K in the second vector? That is, we say, sir, 2. Now we can solve it something like this. Let's first solve it for I. We say, let's solve it for I. I can write I over here. Then. Now hide this first row and first column. So minus 2 into 2 is minus 4. Then we say minus. Minus 1 into 4 is how much? Once again, minus 4. Then we say minus. Now let's solve it for J. So I'll write over here J. Now guys, if you hide this and this, so 1 into 2 is, I say, 2 over here. Then we say minus. 3 into 4 is, we say, sir, 12, minus 12. Then we say plus K. Now solve it for K. So hide this column and first row. So 1 into minus 1, that is minus 1. Okay. Then we say minus. We say 3 into minus 2 is, we say, sir, minus 6 over here. Now I can write it something like this. Guys, minus into minus is plus. So minus 4 plus 4, this will come out to be, so 0 I cap. Minus. In this case, we say 2 minus 12 is minus 10. Minus into minus becomes plus. We say, sir, 10 J cap. Then we say plus. Over here we have got K. and minus into plus, minus is plus. So plus 6 minus 1 is plus 5. 5. So I can write this is 10j plus 5k. 10j plus 5k. So this is the value exactly over here. Guys, please tell me in the chats. Please tell me in the chats if everything is crystalline clear. Please tell me in the chats if everything is crystalline clear. Guys, is this crystalline clear? Is this crystalline clear? Guys, tell me, is this crystalline clear? Okay. Great, 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 great. This is how we actually solve the determinant. This is the rule to solve the determinant. Okay. So my dear friends, let me give you a question which is your homework. Let me give you a question which is your homework. Okay. Question is find we say A cross B. Find A cross B. If A vector is equal to 3i cap plus 4j cap. Here, no k cap is present. So if no k cap is present, in that case, you have to take, we say 0, 0, 0, 0, 0 k cap. And we say B vector is, we say 4i cap plus 4j cap. And in this particular case, you guys are supposed to tell me, and we say comment down the answer. So you have to comment down the answer later on in the comments. Guys, if you have not liked this session yet, I would want you guys to like this session as soon as possible. Okay. Okay. And do let me know in the comments how was the session later on when I end the live stream, not right now. So my dear friends, let me just tell you, that is, we say price have been dropped. If you're looking to basically join, if you're looking to join the Unacademy's Plus subscription, like we have recently launched Phoenix 3.0 batch. Okay. So if you want to join that, we say you can join it as soon as possible. You can join it as soon as possible. So this is live from, we say 8th July to 15th July. So you can join it, and it is right now only, we say now right now only Plus subscription is for 5,499 and the prices are going to rise, that's for sure. So if you basically want to save your money, we say this is the biggest opportunity right now to join the Plus subscription. Even you'll be getting the access to all the batches. Not just one batch, you'll be getting the access to all the batches. So you can join it as soon as possible. Okay. So, and most importantly, all the batches, test series, study material, everything will be given to you. So join it if you have not joined as soon as possible. Okay. So my dear friends, and this is basically Phoenix Pro. And what is Phoenix Pro? What is Phoenix Pro? We say access to the special rankers group SRG online batch, exclusive mentorship session by educators, raise a hand in class, doubt and solved instantly. All of these features will be in the Phoenix Pro. We are introducing this Phoenix Pro. So it is just for 5,499 rupees. So I would want you guys to join it as soon as possible if you have not joined yet. Okay. So So, thank you so much. Take care and bye bye. So, guys, please do let me know in the comments how was the session, because we keep on seeing your comments every single time. So, once I end the live stream, afterwards, put up the comments. How was each and everything? Did you understood or not? So, thank you so much. Take care and bye bye. Take care and bye bye.